Okay, so we're now going to talk about evaluating expressions. This is one of the most important things you will do all year, which is why I'm recording this. It's dimensional analysis. Okay, so you've been doing dimensional analysis all along. All of your stoichiometry that you did in chemistry is dimensional analysis. It's also known as factor label. You did it in physical science. You did factor label conversions. The part of that that's really the dimensional analysis, we talked a little bit about what dimensions are. So we have a quantity that we're measuring, we have a unit, a dimension that we're measuring, and we have a unit that we're using to describe that dimension. Dimensional analysis is checking your units, in essence. So when we do giant, hairy algebra problems, which we will do problems that are mostly algebra that take a whole page. You're doing that level of rearrangement and that level of work, and you're checking your algebra straight through. When you do that, you can screw up your algebra pretty easily. I do it. Not as much as I used to. You know, teaching physics has been better for my algebra than anything else. But it's really useful to be able to go back and have a secondary check on your algebra. So here's how we do that. Velocity equals delta x over delta t. What am I saying? Velocity is equal to how far you go and how long it takes you to get there. What are the units that we typically would use for velocity in physics?
Meters a second.
Meters per second. What are the units that we would typically use for distance in physics? Meters. What are the units that we would typically use for time? Seconds. What we're looking at is the expression that we have there and saying, is this a true statement? You know, does meters per second equal meters per second? If the answer is yes, then we assume that the algebra is good or the formula is good. If you pull the formula out of your brain in the middle of a test, you will have note cards in here. You don't ever have to pull the formula out of your brain. Though I have had students who have lost 15 note cards and they're too embarrassed on their 16th note card to say, you know, Katie, can I borrow your note card? Because you can copy a friend's note card before a test. And they'll just try to recreate it from scratch, which is a really bad thing to do because you're prone to reversals. So what if, you know, you're recreating this from scratch and what you come up with is v equals delta t over delta x. What are the units that you have there? Well, you've still got meters per second for velocity, and delta t would be in seconds, and delta x would be in meters. Is that a true statement? No. You're saying that one, it's equal to its own reciprocal. So you immediately can look at that and go, I have a problem. You do the same thing as we're rearranging big, hairy equations in terms of checking your own units. A delta t squared equals delta x. Is that true? What units do we use for acceleration in physics? Since we're always using meters and seconds. Meters per second squared. So I have meters per second squared times what? Seconds squared. Equals, what's my distance for, or what's my unit for delta x? Meters. Is this a true statement? So this one isn't as straightforward because you actually have to do the multiplication. So if we do the multiplication, we end up with, let me shrink this and move this on Bryce's copy, ms squared over s squared equals m. If you would be so kind as to look at the cartoon on the next page, that's where I'll leave you, and then we will do Fermi's tomorrow. My hobby, abusing dimensional analysis. Planck energy divided by the pressure at the Earth's core times the Prius combined EPA gas mileage divided by the minimum width of the English Channel equals pi. It's correct with an experimental error and the units check out. It must be a fundamental law. What if they build a better Prius? Then England will drift out to sea. Okay? I love XKCD. I encourage you all to read it. I can't share all of them. Some of them are a little bit, well, it's aimed at an adult audience. But just because the units check out doesn't mean it's true. But if the units don't check out, you know you have a problem. That's the point that's being made here. So if you're checking a formula and the units check out, it doesn't mean you have the formula right, but you've eliminated your first red flag. So I always check units. If you would be so kind as to gather up the meter sticks, we will pause there. Your homework for tomorrow is watching the video that's linked on the PBWorks page. It's the Fermi, this is perfect. So it's a 4-minute video about Fermi estimations. And when you come in tomorrow, I will start from the basis of assuming that you have watched that. Okay? That's it.